What's up, chemistry class? This is Hunter Hicks with my article and poster presentation. As you can tell, I'm doing a video because I'm not going to be in class that day, and I hope this can be somewhat entertaining to watch. So, my article I'm doing this on is The Mysterious Jellyfish Diet Gets a Fresh Look. The reason it's titled like that is because jellyfish aren't really studied too heavily in the land of research, at least marine biology research, and that's why. So if you go read the abstract of this journal that the article is published or written on, there's a huge disclaimer at the top, kind of explaining how there's not enough research in this field in the first place, and that's kind of the whole premise of why they started looking at their diets and studying the food web and the role they play in it. The big thing that this article kind of covers is that jellyfish play a big role in, being predators in the food web and also prey to other larger predators. But their ability to break down certain nutrients and their ability to build up and pass on other nutrients. So they're studying the stable isotopes of carbon and nitrogen, and they're also studying their fatty acid composition and their digestion. And with this, they're able to isolate, certain fatty acids, and we know how much fatty acids a certain food item might contain. So they're looking at brine shrimp, and they're also looking at Antarctic krill. With this, they're able to see how much they're absorbing and how much they're degrading in terms of the nutrients that these prey are passing on to the jellyfish. The jellyfish they are looking at is the moon jellyfish and the Japanese sea nettle. And the two food items they are controlled feeding are the Antarctic krill and the brine shrimp. The Antarctic krill has a higher level of fatty acids than the brine shrimp, and they are both being fed the same volume by mass. So there's you should be able to see that the jellyfish is getting a higher level of fatty acids from the krill when they are consuming it. And what surprised the researchers is that wasn't the case. What they found out is that these jellyfish were actually producing their own omega-3s and omega-6s, which are fatty acids if you don't know. And from that, they are, concluding that these jellyfish have to be synthesizing their own omega-3s and omega-6s within their own digestion rather than anabolically achieving it. And also, if you don't know, anabolic means they are building up certain nutrients. And if you can imagine, I'm sure you might have heard, if you consume too much tuna, you might get mercury poisoning. And that's an anabolic process where these predators are consuming, lower level items or lower level prey, and they are building up mercury over time. And that's why it's advised if you're pregnant not to eat so much tuna or really any large predator in the ocean, because you might get mercury poisoning. But what's so important with this and what applies to chemistry is it's another way for us to study and possibly see another way to synthesize this, possibly in a lab or in another controlled setting. And it's really, I'd imagine pharmaceuticals or whoever's producing vitamins is probably going to dive a little deeper into this to figure it out and what's going on, because the fish oil market as a whole is worth like $1.7 billion in terms of its market size. It's a really profitable area for these companies to get into. So I think they're probably, all excited and tickled pink by this idea that, there's an animal producing it within its own digestion. As always, though, thanks for listening. I hope you guys have a wonderful summer, and let's kill this finals week. Peace.